morning children. In today's class we are going to learn some different examples based on sets. Example 1.1, find the number of subsets of A x such that x is equal to 4n plus 1, 2 less than or equal to n less than or equal to 5, where n belongs to the set of natural numbers. What do you mean by capital N? It means 1, 2, 3, 4, 5 and so on. Here we are given 2 less than or equal to n less than or equal to 5. What does it mean? We need to write the various n values, that is a natural number, and it is between 2 and 5. Here equal comes, so I can include 2. 3, 4, here also equal comes, so I can include 5 also. So these are n values. According to the condition, n is a natural number and n is between 2 and 5. Now what is x given? It is 4n plus 1. When n is 2, x is equal to 4 into 2 plus 1. 8 plus 1, that is 9. When n is equal to 3, x is 4 into 3 plus 1. 12 plus 1, that is 13. When n is equal to 4, x is equal to 4 into 4 plus 1. 16 plus 1, that is 17. When n is equal to 5, x is equal to 4 into 5 plus 1, which is 20 plus 1, and that gives us 21. As I know the various x values, let me write the set A, that is x 4n plus 1. So the values that I arrived at 9, 13, 17, 21. How many elements are there? We call cardinality of A, that is n of A. n of A is 1, 2, 3, 4. There are 4 elements in the set A. But my question is number of subsets. What is the formula for number of subsets? Number of subsets equal to 2 power n of A. Here it is 4. So number of subsets is 2 power 4. 2 power 4 tells us 2 into 2 into 2 into 2, that is 16. So number of subsets are 16. Example 1.2. In a survey of 5,000 persons in a town, it was found that 45% know language A, 25% B, 10% C. 5% A and B, 4% B and C, 4% know A and C. 3% know all the 3 languages. Find how many know only A. This problem can be done in 2 methods. The very easy method is Venn diagram. Let us consider the 3 languages as the 3 sets A, B, C. As I read the question, let me start from the back. That is all the 3. When I have the 3 sets, this portion tells me the persons who know all the 3 languages. So this part common for A, B and C. We are given 3% know all the 3 languages. So let me consider 3 here. Following the previous line, 4 knows A and C. So we are in A and C, this full part. In the full part, this is 3. So this will be 4 minus 3, that is 1. And proceeding, 4% know B and C. So this is B and C portion, but I do not want this. I want only how many know only A. So let me proceed over here. The previous line, 5% know only A and B. So 5 knows A and B. But this common part, let me subtract. So I get 2. Now what about A? The previous line, let us go. It was found that 45% know language A. So this is totally 45 for the full red circle. The full set A consists of 45%. In that, I want only this portion. So this portion tells only A. So if I want only A, let me subtract the common portions. So which are all common? 2, 3, 1. So let me subtract 2, subtract 3 and subtract 1. So my answer is 39. So using Venn diagram, I easily derive how many of them know only A. So from the Venn diagram, let me write the answer. From the Venn diagram, 39% know only A. But my question is not in percentage. It is mentioned 5,000 persons in a town. So, how many persons? How to calculate? Number of persons knowing only A will be 39% tells me 39 by 100 of the total, that is 5,000. As I multiply, I get 1950. So 1,950 persons know the language A alone. The same example can be done using the formula. As I read the questions, language A 45%. We have taken N of A, N of B, N of C, like that way. Each thing I can also find out 45% of 5,000. 45 by 100 into 5,000. So that gives me N of A equals 45 by 100 into 5,000, that is 2,250. Similarly, N of B 25 by 100 into 5,000. N of C 10 by 100 into 5,000, and similarly we have written the remaining. What is the question? How many know only A? Only A tells me A alone. B I don't want, C I don't want. So A intersection, B I don't want means B complement. C I don't want means C complement. So A intersection B complement, intersection C complement. To find out this, let us use De Morgan's law. So N of A intersection B dash intersection C dash can be rewritten as N of A intersection B dash intersection C dash is nothing but B union C the whole dash. B union C, here intersection comes, we'll put union and the whole dash, that is De Morgan's law. Now how to find out A intersection some set dash? Look at this Venn diagram to remember easily. A set, B set. This is A intersection B. And what about this part? In A but not in B. So A intersection B dash. What about this part? In B but not in A. So B intersection A dash. Now how to find this A intersection B dash? The whole blue circle, that is A, minus the common portion, that is A intersection B. So whenever I want A intersection B dash, my formula is A minus the common part, that is A intersection B. Applying this formula here, this is N of A minus A intersection B. So it is A minus A intersection this bracket. Instead of B, I have B union C. So A intersection B union C. How to write this? N of A minus. How to write this one? A intersection B. Distributive law. A intersection B union A intersection C. A intersection B union A intersection C. And cardinality can be split. So it is N of A minus N of A intersection B union A intersection C. So we have used distributive law for intersection over union. The next step, how to write union. So what is the formula? N of A union B is N of A plus N of B minus N of A intersection B. So using the formula here, first set write as it is. This is N of A intersection B plus N of A intersection C minus N of A intersection B intersection A intersection C. I am just using addition theorem. N of A union B is N of A plus N of B minus N of A intersection B. In this problem, A is A intersection B, B is A intersection C. So N of A intersection B, N of A intersection C minus N of the common portion A intersection B intersection A intersection C. Whenever I put intersection, there are two letters which are same. Do I have to repeat? No. I am looking for common portion. So A intersection I need not put twice. So I will rewrite this as N of A minus N of A intersection B minus into plus again minus N of A intersection C minus into minus is plus N of A. For two letters, let me put only one A intersection B intersection C. Let me substitute the values. What is N of A? 2250 minus. What is N of A intersection B? 250 minus A intersection C 200 plus A intersection B intersection C, it is 150. As we subtract and add this, again I arrive at the answer 1950. So whether we do it using Venn diagram or theoretically using intersection union complement formula, we arrive at the same answer. You can choose your own method. We'll see the steps once again. A intersection B dash intersection C dash. This part I am using De Morgan's law. So De Morgan's law states B dash intersection C dash is nothing but B union C the whole dash. When I want A intersection some set complement, look at the Venn diagram to understand easily. A intersection B is nothing but A and B the common portion. So what is A intersection B dash? It is A minus A intersection B. So we can write B union C the whole dash intersection with A as A minus A intersection this part. By using distributive law, it is A intersection B union A intersection C. Again, I use addition theorem, that is union formula. First set plus second set minus intersection of both the sets. So N of A union B is N of A plus N of B minus N of A intersection B. Applying that, here I have two A's. So one A I can cut because it is all intersection. I can simply write A intersection B intersection C. Take the minus sign in and simplify. Substituting the various values we have calculated, we arrive at the answer 1950. So these are the persons who know only the language A. Example 1.3. To understand this problem, let us remember the Venn diagram again. Consider two sets A and B. We know this is A intersection B. A intersection B is a subset of A. All of us know A intersection B is a small portion that is contained in A. Similarly, what is A union B? A and B together. A and B together. So, A union B, I will say, contains A. Look at the difference. A intersection B is a subset of A, whereas A is a subset of A union B. How to apply this in this problem? I want to show first set union second set. We have some answer. Let me take this alone. This is first set to concentrate. In this, which is the common letter, let me check. A. So A is common in both the sets. This set A and intersection something. This set A and intersection something. So what did I understand from here? A intersection B is a subset of A. So I will write A intersection some other sets. A intersection B dash intersection C dash. So A and intersection some other sets. Definitely contained in A. That is what I want to apply from this. So A intersection some other set contained in A. But I know A is contained in A union B. So this is contained in this set because this is A union some other set. So A union B dash union C. So automatically I understand this set is contained in this set. So this implies A intersection B dash intersection C dash is contained in A union B dash union C. Now this is smaller set and this is bigger set because it is contained. Whenever I want intersection, I will write the small set only. This is subset of this. Therefore, intersection tells me choose the smaller set. Intersection tells me choose the smaller set. Out of these two, this is smaller. So my answer is A intersection B dash intersection C dash. So the entire first bracket, I have identified the answer A intersection B dash intersection C dash. In the similar argument, let us go on to the second one. Here, these two I want the intersection. Choose the common letter. A is not common, B dash not common, but C dash is common. So, when I choose these two, here C dash is coming, here also C dash is coming. So, let me use C dash as the base. What will I say? B dash intersection C dash. A intersection B contained in A. Here B dash intersection C dash contained in one of the letters. So here C dash I am choosing because C dash is the common letter. So B dash intersection C dash is contained in C dash. But C dash is contained in C dash union some set. Here I have C dash union some set. So A union B union C dash. A contained in A union some set. So C dash contained in C dash union some set. So out of the two, I will derive B dash intersection C dash contained in A union B union C dash. Now which is smaller? B dash intersection C dash. Which is bigger? A union B union C dash. So out of the two, this is smaller set and this is bigger set. Now what is my question? A union B union C dash intersection B dash intersection C dash. Whenever I want intersection, out of the two sets, I must choose the smaller. Union tells me choose the bigger. Intersection tells me choose the smaller. So here the symbol is intersection. Out of the two, this is smaller. So my answer is B dash intersection C dash. So the entire first gives me this answer and the entire second gives me this answer. Now I want union. So what is my question? A intersection B dash intersection C dash. Union B dash intersection C dash. See which is common in both. Here also B dash C dash. Both are common. B dash intersection C dash is in both. Which is bigger set now? Here B dash intersection C dash. Here B dash intersection C dash intersection some other set. So this is intersection, smaller set. This is intersection but only two sets. Here intersection, one more set is there. So this or this is smaller and this is bigger. My question is union. Intersection means choose the smaller. Union means choose the bigger. So my answer is B dash intersection C dash. So remember, whenever I want union, out of the two, choose the bigger set. Because one is contained in the other. So A intersection B. Which is smaller? A intersection B. But A union B. Here A is smaller, A union B is bigger. Union means choose union as my answer. Is the idea clear? Here this is smaller set, this is bigger set containing that. So when I want intersection, I will choose the small set. When I want union, A contained in A union B tells me A union B is my answer. So here I have union out of the two. This is contained in this. So this is my answer and that is the RHS. So we have proved that A union B dash union C intersection A intersection B dash intersection C dash. Union A union B union C dash intersection B dash intersection C dash is equal to B dash intersection C dash. So out of these two, we have chosen this as the answer. Out of these two, we have chosen this as the answer. For the total union, I will choose B dash intersection C dash as the answer. Example 1.5. If A and B are two sets, so that n of B minus A is 2 times n of A minus B, which is 4 times n of A intersection B. And if n of A union B is 14, then find n of power set of A. Look at the values given in the question. It has A minus B, B minus A intersection B and A union B. Let us see the relation between all this. If I consider this as A and this as B, this portion I will call A minus B. This portion I will call A intersection B. And this portion I will call B minus A. So, A union B, the full portion, can be written as A minus B, A intersection B, B minus A. So I can take n of, the cardinality is nothing but n of A minus B plus n of A intersection B plus n of B minus A. So, all the three parts which are disjoint. A minus B is not touching A intersection B, which is not touching B minus A. So, these three are disjoint sets. All the three, when I add up, I get A union B. So, n of A union B is n of A minus B plus n of A intersection B plus n of B minus A. Having known this relation, let us identify each thing separately. So, here any one, let me take K. So, let me assume let n of A intersection B equal to K. Combining these two, n of B minus A equals 4 times n of A intersection B, whereas 2 times n of A minus B equals 4 times n of A intersection B. So, I am comparing these two. n of B minus A equals 4 times. What is n of A intersection B? That is K. Here 2 n of A minus B equals 4. n of A intersection B is K. Cancelling the 2 here, I get n of A minus B equals 2K. Now, let me substitute these values in this formula. What is n of A union B? Given it is 14. What is n of A minus B from here? 2K. n of A intersection B from here? K. n of B minus A from here? 4K. So, I get 14 equals 7K. K equals 14 by 7, that is 2. Once I know K value, let me substitute here. n of B minus A is 4 into 2, that is 8. n of A minus B is 2 into 2, that is 4. As I know, n of A minus B, n of B minus A and n of A intersection B, that is simply K, and K value is 2. What is my question? N of P of A. So, I want n of P of A. The formula 2 power n of A. But how to get A? So, let us proceed. What is A actually? A minus B union A intersection B. So, I can write n of A is nothing but n of A minus B plus n of A intersection B. A is nothing but A minus B union A intersection B. So, n of A is nothing but n of A minus B plus n of A intersection B. So, what is n of A? n of A minus B 4, n of A intersection B 2, together it is 6. Now, I want 2 power 6. So, 2 power 6 is 2 into 2 into 2 into 2 into 2. 6 times we multiply and my answer is 64, and that completes the answer. Let us go through the answer once again. Given B minus A minus B, A intersection B and A union B. We see the Venn diagram to understand better. A minus B, A intersection B, B minus A. All the three together contribute A union B. As I put n, I can put plus symbol. So, n of A union B is n of A minus B plus n of A intersection B plus n of B minus A. Now, coming back here, any one, let me give a new name, say K. If this is K, compare this and this, find out n of B minus A. Compare this and this, find out n of A minus B. As I know n of A union B value and formula, let me compare. I arrive at K value. So, this is first part, second part, third part. Once I know K value, put it back here and here, arrive at the values. Now my question is n of p of a. What is the formula? 2 power n of a. So I need to find out what is n of a. Back to the diagram. A is nothing but joint of a minus b and a intersection b. So n of a is n of a minus b plus n of a intersection b. As I add both, I arrive at the answer 6. 2 power 6 gives me 64. So n of p of a is 64 and that completes the answer. Example 1.6. Two sets have m and k elements. The moment I read this, let us name the sets. Let a, b be the two sets. They have said they have m and k elements. So n of a is m and n of b is k. Proceed on to the next line. If the total number of subsets of the first set, subsets when I say number of subsets of a, what is the formula? 2 power n of a, that is 2 power m. So number of subsets of b, obviously 2 power n of b, that is 2 power k. They have given total number of subsets of the first set, that is 2 power m. Is 112 more than that of the second set? So first set is 2 power m and the second set is 2 power k. The first set is 112 more. That is, if I subtract, I will get 112. Now my question is to find what is m and k. So it's a little tricky question because they are two powers. Let me factorize this as powers of 2. So 112, as I put 2, I get 56. Again, 2 gives me 28, 14, 7. So I get 112 is 1, 2, 3, 4. So 2 power 4 into 7. In these two, obviously m is bigger. Because 2 power m minus 2 power k we have written. So m is bigger. Take 2 power k out. Whenever I take the power, we have to subtract. That is 2 power m. I divide by 2 power k. That is 2 power m minus k. Minus, if I take 2 power k, there is nothing remaining. Say it is 1 time. Compare these two. I should have 7 as this answer and 2 power k as this answer. It's little tricky question. We just guess because this is 2 power 4 into 7, the RHS. That is the only way of writing if I represent it as 2 powers. Here I have like this. So let us compare. 2 power k I compare with 2 power 4. 2 power m minus k minus 1 I compare with 7. As I compare, I get k value 4. Now substituting in this, 2 power m minus k minus 1 equals 7. But k is 4. So 2 power m minus 4 equals 7 plus 1. 2 power m minus 4 is, this is 8, which can be written as 2 power 3. As I compare the powers, I get m minus 4 equals 3 or m is equal to 3 plus 4, that is 7. So we have found out m value is 7 and k value is 4. The question is to find the value of m and k, and m equals 7, k equals 4 is the answer. Let us go through the steps once again. As we name A, B as the given sets, m, k are the number of elements. So n of A is m, n of B is k. They have given the number of subsets. The moment I read number of subsets, I read 2 power m and 2 power k. 112 more tells me 2 power m minus 2 power k is 112. Take 2 power k out. As we take power k out, it is 2 power m minus k, because whenever I take a number, I divide. 2 power m divide by 2 power k is 2 power m minus k. 2 power k by 2 power k is 1. The RHS, because the LHS is 2 power, I am trying to write RHS also as 2 powers. As I divide, I get 2 power 4 into 7. 2 power k, 2 power 4 compare, and the next bracket we compare with 7. This tells me k is 4. As I substitute k as 4 and minus 1 I bring to the right as plus 1, which reduces to 8, and 8 is nothing but 2 power 3. As I compare, the base is same. The index should be same. M minus 4 is 3. M is equal to 3 plus 4, that is equal to 7. Example 1.7. If n of a is 10, n of a intersection b is 3. Find n of a intersection b the whole dash intersection a. Let us start from here. It is n of a intersection b the whole dash intersection a. Forget n at the present. Let us find out what is a intersection b the whole dash intersection a. Using De Moivre's law, a intersection b the whole dash can be written as a dash union b dash intersection a. We use distributive law like this way. So I write a dash intersection a union b dash intersection a. A dash intersection a union b dash intersection a. A dash intersection a is nothing but empty set. Union b dash intersection a. So this can be simply written as b dash intersection a, or I can very well write it as a intersection b dash. What is a intersection b dash? This can be written as a minus b. We know a intersection b dash and a minus b are one and the same. Now from this Venn diagram, you can simply write what is a minus b actually. N of a minus b is n of a minus n of a intersection b. The full red circle is a. This common portion is a intersection b. I want the remaining portion. So n of a minus n of a intersection b. So let us write down what is expected in the question. N of a intersection b the whole dash intersection a is nothing but n of a minus b. So this full part we have reduced as a minus b. What is n of a minus b? N of a minus n of a intersection b. N of a is 10. N of a intersection b is 3. 10 minus 3 is 7, and that completes the answer. Example 1.9. If P of A denotes the power set of A, then find n of P of 5. We know what is n of P of A. N of P of A is 2 power n of A. Here the question starts with 5. What is 5? It is an empty set. So we denote like this way. What is n of 5? There is no element. So n of 5 is 0. So what is n of P of 5? N of P of 5 will be 2 power n of 5. That is 2 power 0, which is 1. So P of 5 has one element. So one innermost bracket I have completed. Now we have another P. So n of P of 5. P of 5 has one element. P of 5 will tell me 2 power 1, that is 2. Now I want another power set. So N of P of 5. P of 5, another P of 5 we have completed, another P of 5 we want to finish. So what is this? 2 power 2, that is 4. So P of 5 will contain 4 elements.